and welcome to the next installment of ORTHO REAL, the podcast, keeping it real in orthopedic surgery and all things related to healthcare, medicine, surgery, and other interesting topics. Our guest today, Peter Verrillo, is the CEO of Enhatch, an information technology company in the orthopedic space. Peter, hello and welcome.
Hey, Matt, how's it going?
Going great, man. Delighted that you've joined us today. So you have obviously a very strong engineering background, but tell us about you and how you came to where you are in the healthcare and IT space now.
Yeah, it's an interesting story that I feel like I tell it so often because it's the whole reason why we're here as a company. So thanks for having me here and having me go through it with you guys. I started it with a mechanical engineering degree from Stevens, and I'm looking for my first internship. We call it a co-op program. And there's this company called Osteonics on the list, and they were looking for someone who knew how to do CAD. So this is like mid-90s, and I get this job, and I was still like, a teenager at that point. But I find just like this home that I loved at Stryker. And I've developed some great knees with them. Came back after college, after I did a startup in the time frame. I came back and worked at Stryker for another 5 years, developed another knee and a hip, and then I went off to do a shoulder. Each time I went and designed another product and launched another product, all which turned out to be really successful. We had very little data back then, right? We made some decisions based upon X-rays and measurements and some rough studies. But we kept on trying to have this solution. As an engineer, you're always trying to find the right answer, right? The right fit, the right number of sizes, the right instruments. And we had such limited data in that time frame. When I left Stryker to start my own company, that ended up getting acquired by HealthPoint Capital and then Nexo Orthopaedics, and that got rolled up into Tournier by another acquisition 6 months after that. We were on to something interesting where we finally had access to some better CT data. We were finally able to get that, and that allowed us to have a different level of visualization into the human body. So as we kept evolving our understanding of this is now across 12, 13, 14 years from when I started in the industry. There's such a different amount of information in the design of the device. The reason why I was always searching for this is we were looking for the right answer. We're looking for the right number of sizes because it's expensive to make these parts, and it's expensive to make hundreds of sets of all the sizes, and that was always a hurdle at these companies. So that's where we kind of started. And all my experience of designing products and launching products kind of got me to the point in 2012 where we had wrapped up our work with Tournier. They ended up merging with Wright, and now Stryker, as you guys all probably know, owns that still. So Stryker gets everything I've ever designed in the past, and it's a nice way to kind of like take this next part of my journey. So I've launched a number of products in hip, knee, shoulder. I did some work in spine. I did a finger, you name it. And through that time, the things I've learned, I started working on it at Enhatch. So the things that I struggle with as an engineer, and then as later on as like a business manager, working in marketing and working with the team to deploy and launch products, I learned, wow, it's actually hard to deal with sales reps who need content, right? So the first thing we started with was a way to do that so they wouldn't have to email me for the brochure, right? Then we tackled bigger and bigger things over time. We tackled, sales orders. We tackled inventory management. We ended up acquiring a company in 2015 called Surgisoft that had a platform and integrated that into our system. So every year we've just tackled this next part of the industry that we were struggling with. And in 2016, we raised a seed round. And at this point, I've now got like 3.5, 4 years of like tech experience, and I just see this clarity around the future because we were evaluating AI along the way. And this is still early enough that people in tech knew what AI was, but I think the general pop didn't. And we said, well, our investors were from Silicon Valley. They had, big investments in companies like Lyft early and other companies like that. And they said, how do you 10x your product, right? The 0 to 1 concept from Peter Thiel. And we went down this road on Labor Day that year and kind of mapped it out on a whiteboard. And while it's markedly different in many ways, it's expanded even beyond what we originally thought. It's fundamentally the direction we've been going in the past 5 years, is really evolving the industry. And I think it's ready and now it's time, which is exciting because like now everybody's into this and learning about it, and all the companies are starting to really pick up on it.
You've touched on a lot of points there that are great areas we could jump off on for any of them. So your background was in designing joint implants and in working with those. So did that evolve because are we reaching a point, this is a loaded question, are we reaching a point of diminishing returns with that? And so the pain points were elsewhere, and so that evolved your interest into going in different directions with that? Or was it just things that showed up on your radar that you got more interested in, or what drove that transition?
So when I was younger, there was definitely a thing that would happen with me. Once I had successfully completed a project, I felt like, okay, well, I really don't want to do that again. There's, some folks that get stuck into developing, knee after knee after knee after knee. And that's a great path, but I kind of got bored with knee. So then I went shoulder. I did hip for a little bit in between too. Like I actually started as Stryker on a hip project, then moved to knee, and so I did the original Scorpio, but I was young, right? So I was like the drafter, the guy who but my name was on the archives. If you go back in Stryker, my name was on the drawing, doing the drawing, GD&T and that kind of thing. And then I designed my own system, ran my own project, and the next step was, okay, let me run my own company. And every time I just liked that next level, and it was a startup, there was only 3 of us, so it wasn't like this big company, but when we got acquired, that grew and grew. And at each step, I took on more responsibility. I got into marketing and other areas. So it did come back to a lot with me evolving the things I wanted to work on and evolving my own skills. But then after all these product launches, so I had probably at this point 5 or 6 product launches under my belt by 2012, and have all gone on to sell billions. So that's worked out for the companies I work with. But we had such inventory issues. We had such communication issues. I used to have to get on a plane to talk to a doctor and see the problem happen in surgery. Every time, I was just decided to start, and me and my co-founders decided to start solving the problems that we experienced that makes the industry very analog and very outdated. So we were really trying to solve those problems. So, every day we get to affect that kind of future that we're trying to build.
And so maybe that gets to this term that you've used, and that's sort of at the center of Enhatch, of pioneering so-called intelligent surgery.
Mm-hmm.
Give us a framework of what that means when we talk about intelligent surgery.
Yeah, absolutely. So it's funny that a couple of years ago, if you did a search for it, nothing would really come up. Maybe a couple journal articles, and it's usually around a different combination of words. But it's really started to become part of the common language that we use and taxonomy around surgery. So what's nice is that intelligent surgery is really the implementation of artificial intelligence into orthopedics, into surgery. So it could be as simple as helping a warehouse picker choose a certain set of products for a certain size patient. It can be more complex, and the intelligence can be used to predict the best implant size based on an optimization algorithm instead of like a fixed set of sizes, but custom generating the 3D models. But it's going to even evolve beyond where we are now when there's sensors retrieving data intraoperatively. We could take that data and loop it through the optimization and loop it through the intelligence to decide what should the next step be. Should you do that release, or should you cut a little bit more off the condyle? And that's where I feel like the embodiment of intelligent surgery really is just the transition from analog to digital happened, 15 years ago, 20 years ago with navigation. But now the industry is moving towards intelligent surgery. And the other part of this is we have an interesting take on how that's even evolving that I'd love to share if you've got a few minutes.
Absolutely, have at it.
So this past week at Academy, or a couple weeks ago at Academy, we launched the intelligent surgery ecosystem. And the idea with the ecosystem is we're providing a framework for companies to integrate all of their technologies and all of their processes into one simple system and ecosystem. So if you're a large company right now, if you're Zimmer, you're on your own building your ZB Edge, creating your ecosystem of products. But if you're a smaller company, you don't have access to this. Even the mid-sized folks, like folks like Medacta, they have a ton of technology that they're deploying in all these different areas. And if it is all one integrated system, that'd be amazing, right? But a lot of the times there are different silos, and this information doesn't translate. And if you can't get the data from each of the sections of the process of the workflow, you can't learn from it. And that's the goal here. Because if we can make all these assumptions and impressions and ideas around where to put an implant, but if we don't have the clinical outcomes data looped in and we don't have this feedback loop, we're not going to learn. And if we can't learn, then it's not truly, it is AI, but it's not machine learning. It's not where the implants are going to get better.
Yeah, so talk a little bit about AI and artificial intelligence. I think some of us have some concept of what it is, and it's either out there in the future, or it's Skynet from the Terminator movies, or it's kind of becomes this black box of, okay, this, and then AI is in the middle, and then there's some other outcome here. What is that really? Is it computational power to process these large amounts of data, or talk about that, or machine learning for those of us that are on the periphery of this?
It's a great thing to want to know, right? We need to understand this because they all mean different things. So we can go back, to the 50s or 60s, I think, when it was first really starting to formulate, and there was these concepts around AI that really proved it could work. And what happens is in the early days, I don't know if you remember word processors in the 90s, but it was amazing to imagine that you could take a picture of a screen and use optical character recognition to identify the words on the page. And that was when that happened for the first time on a processor on a computer, it kind of blew my mind that was possible. And then obviously through the years that got faster and faster, and it could happen, now almost instantly. So there's this concept of AI's been there for a long time, and we weren't aware of it because there wasn't a lot of media around it. But in the late 2000s, it really started to accelerate again. It was kind of in a winter where there wasn't significant development for many years. And then that's when there was some early results and traction coming out where Google was able to identify a cat versus a dog. If you remember those early press releases. What happened was that we did get a lot more processing power, and it wasn't from a CPU, it came from GPUs. So the GPUs gave us a lot more cores and processors to run simultaneous solutions. And if you can remember your calc college, it's hard to solve a multivariate equation. It's hard to solve those equations like by hand. Computers can do them faster, but if you have more processors, you can run them and run more efficiently. So over the past 10 years, there's been incredible advancement. Something that we dabbled in AI in the early days of Enhatch, and something that would take 3 to 4 weeks can now be done within seconds. Just to consider the difference in speed. But it's also around moving from CPU to GPU, and it's also around the code bases and the frameworks that are out there. So Facebook, Google, all these different groups are developing more and more technology so we can build things faster. And Amazon as well, of course. So all these things are now at our fingertips to accelerate our own development. And what we're building with the ecosystem is to do the same. That we're basically taking all the hard part of the development and coding and servers and scaling out so that companies can now use AI tools like off the shelf, drag and drop into their systems today. So AI is really going to keep advancing. I will say the one thing that a lot of people confuse is it doesn't have to involve learning, like a eventual learning, like a perpetual learning. It can and it should, but there's a lot of different parts of that area of technology. But the ones that are most applicable to what we're all doing really benefit from the machine learning side, which is a subset.
So does the artificial intelligence, does the machine learning, is that what sort of pulls everything together from the ecosystem, if I'm thinking about that right or understanding that? Because we've got so many different things in industry, and especially with joint implants and with a lot of things in orthopedics and healthcare, when we have robotics and augmented reality and additives manufacturing and a lot of these technologies out there that maybe, to your earlier point, can be a little siloed, or they're each kind of in their parallel paths. Is this what pulls them together, or tells us what's important, or what's really going to get us best outcomes for our patients, or make things safer or more efficient, or things like that?
Exactly, and that's always comes back to where we're like, why are we doing this, right? There's a story that is core to our kind of evolution into this world. So for the first 5 years of our career at Enhatch, we were really focused on the development of software, enterprise software, workflow software to help the companies. And then right around the time we started mapping out with the investors what a 10x product looks like, we started really getting deeper into AI. A close member of our family passed from a knee surgery. 4 days after surgery, an embolism. Within 20 minutes, he was gone, and he was kind of like a grandfather to my daughter. It was a tough part of that world for us for that time. They asked me the advice on the surgeon, and there's always this bit of people do this all the time, right? Hey, you do knees, you do hips. Who should I go see? And I usually recommend folks around here. They were based in Florida. I knew some guys down there, but I was like, well, who have you seen so far? And they said who it was, and they were so happy and comfortable with him. And I was like, well, that's the most important part of this, is that you have a trust in the relationship with the surgeon. That's like the most
right.
Unquantifiable part of it, is that when I go see Dr. Barber, he makes me feel good about getting the surgery, and I'm going to come out and I'm going to do well. And later on, his wife, a couple of years later, got knee surgery by the same doctor and had a great result. But that femoral rod in some cases causes issues, right? And every time I think about traditional knee instrumentation, it can be done right. There's ways to get around that. You can flute the rod and you can do these other things. But when we invade the medullary canal, that does add an additional risk level. So, and that's just one, right? You know more than I do about all the different potential complications. And there's there's a ton of data pointing to the fact it's a very safe procedure, but it does happen occasionally. So it's always back to the patient. And this is kind of one of our founding evolutions of the company when we went from workflow enterprise software into AI and into this intelligent surgery world. It was this transition over a couple of years after, thinking about that and feeling that personally that drove us as a company to really push forward in this space. So it always comes back to the patient. The better the outcome, the faster the recovery, the less disruption to their life. And the other part of it is, and now this is really being shown up in the UK, the wait to see surgeon.
Yeah.
So we can't have great results and it takes them 5 years to see us, right? Like that's not good. So the other part of this challenge is that there's, I think, 5.3 million people as of the last reading I had waiting for surgeries in UK because of the COVID backlog, and they were already in a bad place. And even the US, this was a couple years ago before COVID, when our family friend went to get knee surgery after 2 years after her husband passed. She was originally told a 1 year wait. And this is down in Florida, obviously, where there's a high population of folks that need knee surgery. Once they realized who she was, they actually moved her up to just 60 days. But can you imagine waiting a year? Most of the time they push it off 2-3 years to even see the doctor, and then having to wait an additional year. That was crazy. And now it could be 2 years, it could be 3 years. So that's the part of this we also have to think about. How do we make this surgery faster for you and just as safe and just as accurate? That's the place we have to go to, because they're not making 10% more orthopedic surgeons every year. They're making about 1%, right? The U.S. System. We have about 1% more surgeons each year. So that's not a big increase, but we're growing a lot faster as a population and as a disease. So in 10 years, you have to be able to do 1,500 joints a year, Matt. So do you want to just stop having a family life and just figure out how to work 18 hours a day, or do we make the surgeries twice as fast? And that's the direction we have to all look at and go to.
Definitely things to consider. And I've had acquaintances tell me, a year and a half wait for a joint replacement in Canada. Wow. So in North America as well as the UK. Yeah. And maybe too, even on the non-operative side, does AI help us identify who should have what non-surgical treatments, who needs viscosupplement injections, who needs other non-operative pathways, weight loss, cold laser therapy. All the different things that may be available, biologics, all of those different techniques. And can we identify who benefits most from those and who's going to do well that we can buy time for before they're in that pipeline for joint replacement surgeries or things like that? Absolutely. That's a great use case for it. And I've even seen a surgeon a couple weeks ago present on it. And it's a great way to think about where else could AI be used. I've mainly focused around the joint spine world, and I've thought about it from a workflow point of view, because our careers as a team has been sitting in surgeries with doctors, participating, cadaver labs, design, and then obviously the business part of it behind it, the inventory and the tracking and all that. So we're addressing this clinical workflow that affects the surgeon, affects the hospital, affects the medical device company. But there's applications for AI everywhere. And that's one of the reasons why we're building the ecosystem, is that if there's a great researcher or developer who creates a tool they analyze a ton of data, and now they have a way of stratifying the risk for that patient and saying, okay, this patient should go down path A or path B or path C, and path A is the best one for them because of all these reasons.
Well, they should have a way to commercialize and integrate that into the workflow. So that's the kind of tech we're building, is that foundational architecture or network to allow them to easily connect their system into our system that makes them, gives them access to, right now almost 100 companies, but eventually it'll be hundreds and hundreds of companies. So that's the exciting part, that there's going to be this ability to integrate directly into the workflow, and when those technologies exist, and there's people working on them right now. So there'll be more and more every day.
So it feels like you've got solutions at a lot of different points, but for Enhatch, then who is your customer? Who are you most focused on? Is it maybe not surgeons? Is it medical device companies or healthcare systems that you provide an ecosystem and then they scale it out, if you will, where they are already in terms of care delivery? Or how does this take hold?
Sure. So we design for the surgeon. So we think about the surgeon and the patient, right? That's our kind of core focus, is that you're the ones who have to use it and the patient has to experience it and have the results from it. But our customer is often today a medical device company. We've talked to a few hospitals that have expressed interest, and we think there's opportunities elsewhere. I believe there'll be opportunities across any of the participants. I could even see a future where surgeons may be customers on their own, or users, independent of a company. So that's part of how we built the ecosystem. Was after a decade of learning in the industry on how they were evolving the tech side of things, you have to build a really flexible framework to have everybody work together on the same system. So, today we ultimately sell to the device company. That's who our sales reps are, picking up the phone and dialing. But the main effort for us is to make sure we're designing products for the surgeon and patient, that the things they want. And I think that's a pretty common thing in our industry, is that we always worry about those two folks in this equation.
Agreed, and the patient is ultimately the end consumer of this, in conjunction with their physician and the relationship that they have there with their surgeon. So obviously you've been in the industry a long time and just are a smart guy and know a lot about a lot of these things. To take it a little different direction for patients, or just somebody who's not deep in this medical device surgical space, but is just listening to this because they know me or whatever. What should patients be looking for in their healthcare or in their surgery? What do you identify as key things that you're telling people that ask you? What should they be seeking out?
Yeah, I'll still give the same advice, that you have to trust your surgeon. You have to feel confident in their ability to perform the surgery, and the fact that she does a lot of surgeries every year, and of the type that you're getting, right? That's always an important part of this. There's everyone's got to learn, and everyone's got to start somewhere. But I always look, when I do the analysis, I always look to see, okay, where did the doc train, right? And they train under a good system, right? Did they have a good mentor? Did they have a fellowship? I think those are incredible, factors in this, in that you spent your life training to do a certain procedure.
And I think the data backs you up on that too. I mean, I think we do know that surgeons that do these kind of things in high volumes and that specialize on certain procedures do have better outcomes and lower complication rates. And so I would definitely agree with that.
It's true. And, that also means that their facility is ready for it. It also means that it's going to be a more streamlined workflow for the patient. It's going to be, in, get surgery, and out, instead of, more and more complications. I had another, close friend of the family, who had really active person, like working, they were in their 60s and fell off the ladder and went to a community hospital that didn't have a lot of experience. Doc didn't have a lot of cases under the belt, and it was it was tough. Like they just wanted it over with, right? And that's why I recommended they actually were down in Philly. I recommend a couple docs over at Rothman because I know a bunch of the docs over there and have worked with them through the years. But he was in the hospital. He just wanted it over with. But 10 years later, he was still dealing with the complications from that first surgery. And I'm not saying that it was a bad fall, and it was hard.
Sure.
I'm never the one who has to do this, by the way. So I'm always standing behind the guy or gal who's doing it. And but I know it's a hard surgery. But the more you do, the more experience, the more comfort you have, the more trust that you have in that surgeon and the experience behind it. That's a really important part. I also say there's an indication that, and it's not a necessary one, but I think it's really interesting when doctors are looking at newer technologies. And it's not a matter of age. It's not like, young docs like AR and robotics, and old docs just like to use a chisel and a hammer, which no one uses those anymore. But it's more about the idea that you're always honing your craft. So you're always trying to find, is this going to be a better solution for us? You remember this, but doctors don't go into a surgery without having done multiple cases, either virtually or on cadaver, in practice and preparation for a new technology.
Sure.
So like that constant knowledge and learning, when you see surgeons who are interested in these things and trying these things, it's also a good indicator that they're curious, and their process and learning is never going to end. And that's a good sign of someone who's going to be better every time you meet them, because they have more and more of that focused training.
I totally agree with that. And I've known surgeons, 60, 70 plus years old that are still obsessed, and they're just dynamic, and they're thinking about these things constantly, and it just occupies so much of their life and what they do, and they're interested in new parts of it and new techniques. And there are guys that, quite honestly, get out of training and shift their brain into neutral at 35 years old, and are just going to try to replicate the same stuff that they were taught, and it never grows or evolves. Hopefully much more of the former than the latter going on out there. But I agree with you that it's not an age thing.
It's not. I'll never forget one of the only surgeons who could easily outwork me, right? Who was probably more than twice my age when I was working with Dr. John Fenlon out of Rothman. Him and Dr. Mark Lazarus, they were working on a shoulder project with us, and they would go through a full day of surgery. We would drive down to Philly, because we're here in Hoboken, New Jersey. About a 2-hour drive. We'd get into Philly right around 4:00, and we'd have an OR set up, and we'd do some work. We would go until 1 a.m. And they'd still have the energy to keep going, but I had to actually drive back. So it was never about the age, right? It was really about the mental preparation and advancement and learning. And it happens. It's just the type of person that most orthopods are, which is great. And that's why I really love this industry. And where I spent all my career, there's this need for improvement, and it's a very humble group in general.
Yeah, I had the pleasure of interviewing a guy named Dave Tate, a very internationally known power lifter who's had a couple of hip replacements, and we got to talk on the podcast, and he said passion trumps everything. And I think that's what you're seeing with those guys and with people that do it.
You got it.
That's awesome. What's the future? What's out there? What's AI and technology gonna be delivering that you feel like is going to win and is going to be the thing that really delivers?
So when people ask me this, the answer usually bothers a lot of people. So I'm sure if they get to this far in the podcast, there'll be a few folks that complain.
we're keeping it real here. So we want to hear your answer.
Yeah. So let's just have a thought experiment where we imagine that AI keeps progressing at an incredible pace. And because of that, and the processing power keeps progressing at an incredible pace, like it has been. And where we are today and where we are 10 years from now, it could be 5 years from now, it could be, somewhere in between. It's not going to be 20 years from now, but we will be 3D printing more and more parts in the body. And those parts will be probably at first not generated by AI, but they'll be 3D printed, printed parts. So we could, if we think about what we're doing for the past 10 years in orthopedics, a lot of 3D printing, but of general shapes and sizes. Well, the bioprinting world has really been heavily invested in, heavily evolving. There's been some great acquisitions recently by some of the strategics in 3D printing around soft tissue and vessels and areas. So I don't see us that far away. Like definitely in our lifetimes and even in the next decade probably, bioprinted organs, bioprinted cartilage, ligaments. So maybe there's new procedures that we haven't yet thought of because, you could put a cadaver ligament in, but that's only so good. But now you could have your own personal patient-specific bioprinted organ or ligament or tendon, or whatever the piece is that we'd want to replace. And I see that continuing to advance. So there's this flow I've got this great chart that I draw on a whiteboard for folks. And okay, we started here with metal and some plastics, and it's evolving into more complex structures, better results. It'll evolve into maybe a bio knee, like you're 3D replacing instead of a piece of cobalt chrome, it's an actual living piece of tissue that was printed. This is where I think it'll keep evolving, but it'll go beyond orthopedics. It'll go into the simpler soft tissue areas like I was describing, musculoskeletal, and then it'll go into vessels and other areas, and it'll eventually go into organs. So we won't need transplants when we can 3D print a liver or a kidney, and eventually even a heart. And I'm not the engineer that's going to solve that problem, right? I want to be, our company is the engineer that wants to build the delivery system so that you could go print 450,000 hearts this year to keep people going. And the whole idea here is how do we live longer, happier, more active lifestyles? I feel like this is a personal thing where if we could all extend our lives 10, 20, 30 years in a productive way, I just think is what could happen, right? Like Jeff Bezos lived to 120. What kind of crazy innovation will come out of someone like that? Someone who's really, Elon Musk, Matt Barber, right? These guys that are out there doing great things. If we all live a lot longer, how many more years of surgery? How many more experiences?
Well, and you're talking a little bit about health span versus just lifespan too, of that quality of life, and how long are you vital and productive? Absolutely,
yeah. Health span is an important part of it. Is that you're still. I mean, my grandfather passed in his 70s, but he was on a ladder painting side of a wall like 2 weeks before he passed. So that's definitely the goal. We live longer, happier, healthier lives. And when something does come up, it shouldn't feel like a death sentence. It should be a quick, efficient replacement. Just like how we do, 1 million plus knee replacements a year now, that could be happening with all kinds of areas of the body that we hadn't thought. And then I always caveat all this by, well, unless pharma figures out a way to just like inject us with something and we magically repair and regenerate everything. But if pharma doesn't figure that out, I think the medical device world will.
Yeah, and it's kind of an overlap too. I mean, you're certainly talking a lot about the orthobiologics space of, whether we're talking about a 3D printed collagen matrix, and then we use some type of ACI stem cell technology
Mm-hmm.
to replete that with the patient's tissues and then implant it back. There's a lot of potential there. So you think that's even
Mm-hmm.
on a decade horizon here?
Yeah, absolutely. And it'll be the easier ones first, and easier in the grand scheme of things, right?
Sure.
Like there'll probably be kidneys printed in the next few years that get implanted into the body. But and it may not be on that, so it might be like hundreds of thousands of patients at first, but it'll be that those first cases that prove it's possible. And obviously there'll be some failures and there'll be some successes and some challenges, but uh, it should absolutely keep morphing beyond beyond this. And again, I describe it as 3D printing or additive or bioprinting. It may not even be that specific methodology, right? It might be a combination, like you were describing, of different pieces of the puzzle to make it work. But there's just a ton of proof that we're heading in that direction.
Well, and you touched on something that there's part of it that we don't know, right? Because this
Mm-hmm.
technology doesn't develop in a linear manner. It's logarithmic, right? And
Yeah,
so the technology that's being developed right now is what will allow the development and the more rapid development of the technology that's being developed 18 months from now.
absolutely, absolutely. And just to just think about like the tools, right? Like when orthopedics started, it was a hammer and a chisel. They didn't have sagittal saws like we have today that are perfectly crafted to your hand and doesn't have any bounce and weighs a few ounces, right? They were basically kind of chiseling out what they needed to chisel out to make the bone fit. Uh, Before there were instruments, right? You did have some saws, and I've actually seen surgeons do freehand femoral cuts and come out with a decent result. It's incredible to imagine, but that's how it progressed before instrumentation. Uh, it's just incredible to think about these evolution of tools that we have, and the same thing's happening in AI, where say 10 years ago we had some of our own servers we were doing work on, and we still do for things, but I can now go into the cloud and scale that up. Like I don't use it for production purposes, right? I now go to cloud, and Amazon's got this incredible, Azure and everybody else, incredible set of tools for me to build from. Just like you have better tools to do orthopedics, we have better tools to generate the software and the hardware out there. So this all just keeps progressing and improving what's in your hands every day. So it's going to keep happening. It's going to keep happening in rapid pace, and there will be innovations that feel like, how did that just happen? It's going to be like, how did we go from here to there? Because we're having this stepwise level of technology advancement that has never been like this. We've never seen this before. Um, you know, the speed of processing power is moving faster than Moore's law in the GPU world, and it's a completely different level.
So we've talked about some really macro kind of 50,000 foot stuff about tech and AI. Let me bring it down a little bit smaller to stuff
Sure.
that's interesting to me, just in
Yeah.
orthopedics and joint replacement. We do a lot of 3D imaging right now, CT
Mm-hmm.
scans, MRIs, and of course, good old fashioned X-rays, 2-dimensionally. What about a 2D to 3D with AI?
It's like you read my mind here. We've submitted it to the FDA. By the time this comes out, I'm not sure it'll be approved yet, or for clearance. But we submitted our 2D to 3D solution for CT, MRI, and for knees. And what's exciting is that if when that gets cleared, we will have a solution that can work directly off of X-ray, and also quickly. Like this isn't going to be requires a human. It requires effort. It's going to be a very fast, efficient process. So the calculation, the goal is that by the time the patient puts their clothes back on after taking an X-ray, and they're walking over to your clinic, that you have a full preoperative plan in your hand from that when the X-ray was taken to when the patient sits down and you walk in the room.
Wow.
So that's possible now from a speed point of view. We're just waiting for the necessary clearances, and this is kind of like the tools I'm talking about. We're building these foundational tools to help surgeons like yourself, but also the companies and the other folks in the ecosystem to have that data.
Yeah.
Because imagine that you're putting on a virtual reality headset on the patient and kind of showing them how their knee's going to work after you're done, right? And that's their plan right there, not some
Right.
Some random pretty picture movie like image. That's their pre-op plan for their knee.
And I think you can very much make the point that is intelligent surgery, because as we evolve some of these technologies, I think the immediate pushback from some quarters is, oh, it's more expensive, oh, it's this, it's more radiation for the patient. And here, as this evolves, it's getting easier, faster, cheaper, where you've used the tech piece to bridge the gap back to a 2D X-ray and make some of these planning technologies more accessible and faster.
You got it. And X-rays have so much information in them. Just a few images from an X-ray can generate a significant amount of understanding of what that complication is in the bony anatomy. And if we think about where things should go next, where things will go next, it's also the implementation of data that you can get directly off your iPad, patient's motion, or your iPhone, right? Just capture the patient's motion, capture how they walk, how they get out of the chair. Being able to apply that to the algorithm and understand how to repair that patient. And I haven't even got into the details around sensors. We have some interesting tech IP around sensor technology for interop decision making. And if that pans out, it's more data that we're going to be able to feed into the algorithm for you to help understand how to treat that patient. So as we keep evolving the platform and the tools that we give to the surgeons, the engineers, and the companies, it's just incredible to think about what's going to be possible. And like you said, not for more money, but for less money. For the processing power becomes more and more efficient, means it becomes cheaper and cheaper each year.
Right.
So we could actually be saving money and not raising prices, and actually having better outcomes, which is exactly where we want to go. We have to go.
Peter, this has been an incredible amount of good stuff to try to take in and digest here.
Thank you.
If somebody is with a medical device firm, or they're a surgeon, or they need to connect with you or Enhatch, how do they do that?
Yeah, just head to our website and you can chat with any of the folks right there on the site. Start talking. We have a number of ebooks and other things you guys can check out and read on your own if you prefer to investigate a little bit more. But the real easy way is just head there and chat with someone live. And sometimes I even pick up if it's late enough or early enough in the morning.
Fantastic. Well, I appreciate your passion for this and for learning and making us better and making surgery better for surgeons and for our patients. Can't thank you enough for being on. For everybody that's listening, take an opportunity to rate the Ortho Real podcast, share it if you will, and reach out to Peter Verrillo on LinkedIn or Enhatch at their website, as he mentioned. Thanks so much, Peter.